Okay, so in last class, am I audible?
Good evening, sir.
Good evening.
Yes, sir. Audible, sir.
Okay, in last class we were on the Navier-Stokes equation. We derived the Navier-Stokes equation. Then we have solved a pipe flow problem by using the Navier-Stokes equation. Okay, so in that problem we derived the expression to determine the velocity profile in the horizontal pipe by using the Navier-Stokes equation. Now I have given today I have given you an assignment where you have to calculate the values where you have to calculate the volumetric flow rate of a falling film. The fluid is Newtonian fluid, incompressible fluid. The same problem you had solved in the transport phenomena, but by using the Navier-Stokes equation. And instead of shell momentum balance, you have to use the Navier-Stokes equation. The expression will be same. Okay. Now today we will discuss about the new parameter, that is the friction factor. In transport phenomena, we had not discussed the friction factor. I think we had not discussed in the transport phenomena. Okay. Okay. So basic concept behind the friction factor is that you have to calculate the friction inside the pipe. Okay. Suppose the fluid is flowing inside a pipe. So we have solved a problem that if fluid is flowing inside the pipe, the length of the pipe is L, the viscosity of fluid is mu, the density of fluid is rho, and the diameter of pipe is capital D. Then you can say that Q equal to volumetric flow rate. Here the pressure is P naught, at the other side pressure is PL. So you know that the Q equal to pi P naught minus PL divided by 128 mu L d to the power 4. Okay, so this is the volumetric flow rate when you have the pressure drop. In other words, you can say that suppose you have the 2 meter long pipe, suppose L equal to 10 meter. So if you want to float the fluid from one point to the other point in the horizontal point, and there is no potential difference. If you want to flow the fluid from one point to the other point, from point 1 to the point 2, this is point 1, this is the point 2, then this much pressure drop should be required. Okay, then only you can flow the fluid. Or this pressure drop is basically the resistance to flow. Hai na? So if your pipe is 10 meter long, then the suppose P naught is 1 bar, P naught is 2 bar, P naught is 2 bar, and PL is 1 bar, then 2 bar minus 1 bar equal to 1 bar pressure drop is created inside the pipe. Okay. So in the fluid mechanics problems, generally the fluid flows inside the pipe only. Generally in the fluid mechanics, whenever you transport the fluid from one point to the other point, fluid is transported due to the pipelines. Okay. Suppose you want to transport the crude oil from the Gujarat port to the Mathura refinery. So generally, crude oil from the Gujarat, the Kutch port to the Mathura refineries are transported through the pipeline. Then they will distill the crude oil and they will produce the diesel and gasoline. Now they have to transported the diesel from the Mathura refinery to the like Lucknow or Jaipur. So they will again transport the diesel from the Mathura refinery to the Jaipur or the Lucknow by transport by pipeline. Now you have to calculate how much power is required or how big pumps are required to transport to pump the fluid from the Kutch to the Mathura, then Mathura to the Lucknow. So that requirement of power that can be calculated by calculating the pressure drop. How much pressure drop occurs inside the pipeline. Okay. So this pressure drop, you have to calculate this pressure drop. Once you know the pressure drop, you can calculate the power requirement. Okay. So this is the basic concept behind the friction factor. Why the pressure drop occurs in the pipeline? This pipeline is a horizontal pipeline. But why the pressure drop occurs inside the pipeline? Because this solid material, this solid surface will exerted some friction on the fluid, and that's why the velocity of fluid is zero at the solid liquid interface. So this solid surface, the solid surface of the pipeline exerted the friction force on the flowing liquid. That's why the pressure drop occurs inside the pipeline. Otherwise, this is a horizontal pipeline. Fluid, if there is no friction loss, then fluid will flow without any resistance. Fluid will automatically flow from the point 1 to the point 2, because point 1 and point 2 has the same elevation, and the potential energy is same, so it should flow automatically. But due to the friction of the solid surface, solid pipeline, you have the friction losses. Okay, so now friction factor is a parameter which will provide you the magnitude of the this friction loss. Okay, and then once you know the magnitude of the friction loss, you can calculate the pressure drop. Okay, now we will define the friction factor. So the friction factor is a dimensionless number which provides the idea about the magnitude of shear stress. Shear stress produced by the solid boundary as fluid flows. This is shear stress means friction. Okay, by the solid boundaries as fluid flows. Okay, so this is the basic definition. What is the based on the significance? Now, what is the actual definition? This is defined as a ratio of shear stress at wall to the kinetic energy head of the fluid. Okay, so this is defined as this is defined as the ratio of shear stress at the wall and the kinetic energy had of the fluid of the fluid. Okay, basically this is the ratio of how much shear stress is created at the wall and what is the kinetic energy of the fluid. So shear stress is represented by tau W. W means at the wall, value of shear stress at the wall, and kinetic energy of the fluid can be represented by 1 by 2 rho v square average. Okay, so this is the average velocity. Okay, here rho is the density and v average is the average velocity of fluid. Okay, now basically the friction factor is represented by the F. It is represented by the F and that is equal to tau W divided by 1 by 2 rho v square average. Okay, now tau W equal to, this is the shear stress solid, this is the force exerted by the wall on the surface. Okay, so tau W is the shear force per unit area on the wall of the tube. So basically this is the force which is exerted on the wall of the tube. Okay, now you, because tau W cannot be calculated directly, so tau W should be equal to, tau W should be equal to minus tau Rz at R equal to capital R in the old problem, है ना, जो अभी हम problem solve कर रहे थे, in that problem that should be equal to tau Rz at R equal to capital R. Okay, here we represent why we are taking the 2 minus. This minus is for changing the force, for changing the direction of force. Or I will make more clear this, not in this way. Tau W is the shear force per unit area on the wall of the tube. Okay, so minus tau W equal to, minus tau W is the shear force per unit area by the wall on the fluid. So minus tau W is the shear force per unit area by the wall on the fluid. Okay. And when you write the shear force as a momentum, then and tau Rz equal to momentum flux. In that problem, we use tau Rz as a momentum flux. That is negative of the shear force. Momentum flux equal to minus tau Rz as shear force. Okay, when you use the when you define tau Rz as a momentum flux, then minus tau Rz is a shear force. है ना? Because the direction of the momentum flux and shear force are opposite. Okay, so when you write the tau Rz as a momentum flux and when you write the tau Rz as a shear force, the sign will change. Okay, that's why you have the two negative sign. That's why you can write tau Rz at r equal to r, that is equal to, okay, minus and minus, two minus sign है ना, that is equal to tau W. So tau W equal to minus tau Rz at r equal to r. Okay, and now what is the value of Vz? Vz equal to, what is the value of Vz in the original equation? This is for the horizontal pipe only, है ना? We are solving because fluid is transported from the horizontal pipe. So it is better to calculate the friction factors value for the horizontal pipe. P naught minus PL divided by 4 mu L r to the power r square 1 minus r square divided by capital R square. This is the value of Vz. So velocity is maximum. Velocity is maximum at the center of the pipe so where small r equal to 0 at the center, small r equal to 0. So Vz max equal to Vz max, that means maximum velocity equal to P naught minus PL divided by 4 mu L r square. So this equation can be written as, the original equation can be written as Vz equal to Vz max multiply by 1 minus r square divided by capital R square. ठीक है? Now you have to calculate it. You have to calculate the value of the dVz by dr. So if Vz equal to this, Vz max is constant. So what is the value of dVz by dr? So dVz by dr, that is equal to, you have to take the derivative of Vz max in bracket 1 minus r square divided by capital R square divided by dr. Okay, Vz max is constant, so this value will become 0. So you will get Vz max divided by r square. Here r square become 2r. This is the dvz by dr. Now, why we are calculating dvz by dr? Because you have to calculate the dvz by shear stress tau rz at the wall. Okay, so that's why we are calculating this. Now, if the dvz by dr is this much, then dvz by dr at r equal to capital R, that should be equal to 2vz max r divided by r square at r equal to capital R. Now substitute r equal to capital R here, you will get 2vz max divided by r. So this is the vz by vr at r equal to capital R. Now you have to calculate the tau rz. And I have told you we have to calculate the tau rz at r equal to capital R. So from Newton's law of viscosity, that is equal to minus mu, because here we assume the momentum flux dvz by dr tau at r equal to capital R. Okay, substitute the vz by vr from the previous equation. Dvz by dr equal to 2vz max by r. Just substitute the value, you will get the answer. Okay, here the negative sign will also come, right? Because this is in the negative sign, so here the negative sign will also come. Okay, so vz by vmax, just substitute the value, you will get, that is equal to 2 mu vz max divided by capital R. Okay, so this is the value of the drz r equal to capital R. Okay, now that is equal to tau w. So tau w equal to 2 mu vz max divided by r. Now if you substitute the value of the vz max, so vz max equal to 2 mu p naught minus pl multiplied by r square divided by 4 mu l multiplied by r. So r will be cancelled out, mu will be cancelled out, 1 by 4 will be cancelled out, 2 by 4 will be cancelled out. So you will get P naught minus PL divided by 2L R. Okay, so this is the equation number 1. Now the second thing which you have to calculate the average velocity. Okay, so average velocity, because in the original equation you also need the average velocity. And tau w you have calculated. Now you have to calculate T average, V average. Okay, so this is equation number 1. Now we have to calculate the average velocity. For average velocity, first we have to calculate the volumetric flow rate. Okay, so again we can directly calculate the average velocity from the Huygens-Pauli equation. Okay, so we will not go backward. We just use the Huygens-Pauli equation. Because we have already derived it. So that is Q equal to pi P naught minus PL divided by 8 mu L multiplied by R to the power 4. The cross-sectional area of the tube is tube of pipeline is pi r square. Okay, so just divide the average velocity should equal to average velocity V average should equal to Q divided by A. So Q equal to pi P naught minus PL divided by 8 mu L multiplied by R to the power 4 divided by A equal to pi R square. So this pi will be cancelled out. This R square will be cancelled out from this. So here you will get the R equal to the power 4. So V average equal to P naught minus PL divided by 8 mu L multiplied by R to the power R square. Okay, so this is the value of V square. Now you know the value of V square, you know the value of tau W. This is equation number 2. So just substitute the value of tau W and V average in the original equation and get the value of friction factor. Okay, so after substituting, values of tau W and V average from the equations 1 and 2 in the formula of friction factor. You will get, what is the basic formula of friction factor? F equal to tau W divided by 1 by 2 rho V average square. Okay, now tau W equal to, from equation number 1, tau W equal to P naught minus PL by 2LR. So this is P naught minus PL divided by 2L R divided by 1 by 2 rho multiplied by V average, that is equal to P naught minus PL divided by 8 mu L multiplied by R square. Okay, now this 1 by 2 will be cancelled out, this 1 by 2, P naught minus PL will be cancelled out, R will be cancelled out, 1 R will be cancelled out. Okay, and this L will be cancelled out. Okay, so what will remain, that is equal to 8 divided by 8 mu divided by rho r V average square. V average. Rho r V average. Okay. Now this quantity is rho dv rho by mu equal to Reynolds number. Here the radius. So radius can be written in the Reynolds number in the diameter form. So it will become 16 mu divided by rho diameter V average.
एक्सक्यूज मी सर
हाँ
सर फॉर्मूले में हाफ रो वी एवरेज का स्क्वायर है.
एक मिनट रुको. यहाँ पर इसे वी एवरेज करो. वी एवरेज स्क्वायर के बजाय वी एवरेज करो.
ओके सर.
है ना. वी एवरेज की वैल्यू रखनी है हमें. Now this is 16 mu rho dv. So rho dv by mu equal to Reynolds number. So friction factor equal to 16 divided by NRE. 16 divided by Reynolds number. Okay. So this is the basic formula of the friction factor when you have the laminar flow. And this formula is only true when you have the laminar flow, because the Hagen-Poiseuille equation which we have taken during this derivation, and we have taken the Q equal to pi P naught minus PL divided by 8 mu L R to the power 4. So this equation is only true when you have the laminar flow. Okay. Now एक मिनट रुको. Here यहाँ रो dv स्क्वायर ही होगा, है ना. 1/2 रो v एवरेज स्क्वायर. एंड when you substitute the value of v average, you have to substitute the only one value of v average, है ना. So रो v average multiply by v average. So substitute the one value of v average, then only you will get rho dv. Otherwise, how you will get the v average? Okay. So substitute the one value of v average, and one value of v average will remain the constant. Then only you will get this value. ठीक है. तो इसे correct कर लेना. ठीक है. तो for fanning friction, it is called the friction factor, and sometimes it is called the fanning friction factor. So fanning friction factor equal to 16 by NRE, and it basically represents the power loss or the pressure loss inside the pipeline. Okay. And once you know the how much pressure loss is occur inside the pipeline, then you can calculate the power requirement in the pump, and to flow the fluid from the one point to the other point. Okay. Now this equation is only true for the laminar flow region. Okay. For turbulent flow region, this equation is not true. Okay. So for turbulent flow region, we have the more complicated functions. Okay. So the fanning friction, this factor is true for the laminar flow only. For turbulent flow, friction factor becomes complex function of Reynolds number and surface सरफेस रफनेस ऑफ द पाइप, है ना। असल में whenever you use the laminar flow, because laminar flow is very smooth flow, है ना, fluid flows in the layers, so the surface friction will not affect the pressure drop. Okay, so the surface, the characteristic of surface, how much rough is surface is, that will not affect the pressure drop. Why it will not affect the pressure drop? Suppose you have a pipeline, okay, and fluid is flowing in the laminar region, so you have the flow which is in the layers. Okay, so only the layer which is adjusted to the solid material, they will feel the effect of the surface roughness. Other layers will feel the effects of the layer which is directly contact to the exact layer, because just adjacent layer. So the second layer will feel the effect of the first fluid layer. The third layer will be feel the effect of the second fluid layer, but the solid layer will only affect the first layer. So when you take the average, then that surface roughness will not affect the flow, and then that will affect the flow, but surface roughness will not affect the friction factor. And the friction factor is the basic property of the fluid only, and in the laminar flow region. So how viscous is your fluid? What is the kinetic energy in your fluid? That is the V average. Or what is the diameter of the pipeline, or what is the density of the fluid? That will affect the friction factor. Friction factor will not be, friction factor is not the function of the characteristic of material of the tube, okay, in the laminar flow region. But when you have the turbulent flow, then it will become the function of the complex function of the Reynolds number, as well as the characteristics of the surface or the surface roughness. Okay, so how you define the surface roughness? So the surface roughness is defined generally. Okay, the surface roughness is defined generally. Suppose this is a pipeline, and in this pipeline, this is the basically the thickness of the tube, and here you have the rough pipe, you know. So the pipeline, this is the roughness of the pipeline, you know. This is basically due to the, this is the characteristic of the tube. If you are using the cast iron tube, the roughness will be different. If you are using the stainless steel tube, the roughness will be different. If you use the copper tube, roughness will be different. If you use the Teflon tube, then you have the very low roughness, you know, based on the material and based on the how that you cast the pipe, you know, which method you are using to construct the pipe, that will affect the roughness. Okay, so basically there is a distance. This is the rough pipe. So in the rough pipe, you have this distance. Suppose this distance is the roughness, thickness of the roughness. Okay, surface roughness height, the thickness of the roughness is xi, and the diameter of pipe, internal diameter of the pipe is capital D. So the surface roughness is defined by xi divided by D. This is called the surface roughness factor. This is again the dimensionless factor because both has the dimension in the meters or the centimeters. Okay, so this is the surface roughness factor. So for turbulent flow, the Fanning friction factor or the friction factor becomes the function of Reynolds number and surface roughness factor. Okay, and this function will depend upon types of fluid. This function is depend upon which region you are flowing. Like Reynolds number is like 5,000 to 10,000 or 10,000 to 20,000. This function will also depend upon the material. This function will also depend, it is an isothermal condition. This temperature is constant or temperature is increasing or temperature is decreasing. So there are different factors which may affect the function. So Fanning function factor is a very complex function of the Reynolds number and the surface roughness. For the simple cases, when you have the simple fluid like water or simple fluid like oil, or when you have the isothermal condition, we will also use the Moody's chart. So Moody chart is very famous chart to calculate the friction factor. So the next topic is Moody's chart. So basically the Moody chart correlates the friction factor to Reynolds number and Reynolds number and surface roughness factor. For simple fluids, flowing in the tube, at isothermal conditions. Okay, so basically Moody chart is first developed by the civil engineers, then again modified by the mechanical engineers. So this chart is generally a rough. This chart is used for rough calculation. How the friction factor to calculate. This is used for basically the calculation of friction factor when you have the when you know the Reynolds number and you know the surface frictions. Okay, and this is only true for the tubular circular tubes when you have the simple fluids like water or simple oil or gas, any simple gas, or when you have the isothermal condition. That means the temperature is not changing throughout the pipeline. Okay, so these are the conditions for the Moody chart. And now I am plotting the Moody chart, how it's look like. Original Moody chart you can find in the book. Next class I will also show in this PPT and how the Moody chart look. So I'm just plotting the Moody chart, rough diagram of the Moody chart. So in the y-axis you have the friction factor. Moody chart is the log-log chart. Okay, this is the log-log plot. In the x-axis you have the Reynolds number. here it will start from the 100, then you have the value 1000, then again 10,000, because this is the log graph, so you are increasing by the magnitude, then 10 to the power 6, then 10 to the power 7, then 10 to the power 8. Like this, you have the Reynolds number range. Okay. Now, in the y-axis, you have the friction factor, which starts from the 0.001, 0.001. Then you have, in between, you have the 0.01. And at upper case, you have the 0.1. Okay. So in between, you have the other points 0.001, 0.002, 0.003, 0.004. Like this, you have all the points. Okay. Now, this is 1000, this is 10,000. So up to this point, you have the laminar region. Up to this point, you have the laminar. 2100 is the point where you have the laminar region. Suppose this is the 2100. So this is the laminar region. And again, here you have the turbulent region. And the Reynolds number more than 2100, then you have the transition, then turbulent region. Okay. So in laminar region, fanning friction factor equal to friction factor equal to 16 by nRe. Okay. So this can be represented by a straight line in the log plot. Okay. Because this can be represented by a straight line in the log plot. So this is basically the straight line which shows the correlation between the Reynolds number and the fanning friction factor in the log graph and in the Moody's graph. Then in the turbulent region, you have the several curves. This is curve number 1. Then this is curve number 2. Then this is curve number 3. Then you have curve number 4. In this way, you have the several curves. This is curve number 4. Okay. So this last curve is for xi by d equal to 0. That means very smooth pipes where xi by d equal to 0. This is the first plot, the bottom from the bottom. The second plot is for xi by d equal to 0.0001. Okay. This is for the third plot is for xi by d equal to 0.0003. The fourth plot is for xi by d equal to 0.001. And this fifth plot is for xi by d equal to 0.003. In this way, you have the several different plots, and based on the different diagrams, you may find the higher number of lines or lower number of lines. So how to determine the value of the friction factor by using the Moody's graph? First, you have to select the Reynolds number. Suppose your Reynolds number is 1 lakh. So select the Reynolds number 1 lakh. Then what is the value of the xi by d? Suppose the value of xi by d for your system is 0.0029. So the 0.00029. So 0.00029 is near to 0.0003. So goes from the 10 to the power 6 to curve 3. This is the curve 3. Here you have the value 0.0003. Then moves in the horizontal direction, you will get the exact value of friction factor. Okay, in the numericals, even in the exam, I will give you the Moody's chart with question paper, and you have to calculate the friction factor yourself by using the Moody's chart. Okay, so you should know how to calculate the friction factor by using the Moody's chart. Okay, where in the exam you will get the problem to calculate the power requirement in the pump or the pressure drop. You have to calculate the pressure drop around the system, so that you can calculate it by using, first you have to calculate the fanning friction factor. From fanning friction factor you can calculate the pressure drop. Okay, so the fanning friction factor can be calculated by using the Moody's chart. Okay, I think this is enough for today's class. We will continue this lecture
Yes,
in the
sir.
next class. ठीक है
सर
हाँ बोलो.
सर अपना रोल नंबर ऐसे कब तक चेंज होगा?
वो बात करनी होगी एग्जामिनेशन सेंटर में. तुम लोग की मार्कशीट आ गई क्या?
नहीं नहीं आई है ना, मार्कशीट के बारे में पूछना था, रिजल्ट नहीं आया हमारा।
सबकी आ गई, हमारी नहीं आई है।
नहीं माँ, अभी तो अब रिजल्ट ही नहीं आया होगा तुम्हारा फर्स्ट ईयर का.
नहीं नहीं, अभी आ गया 2K19 बैच का, बाकी ब्रांचेस का।
अच्छा आ
हाँ
गया
सर,
तुम्हारा.
थर्ड सेम का आ गया, हमारा नहीं आया।
अच्छा तुम्हारा अभी रिजल्ट नहीं आया है. तुम्हारा रिजल्ट
नहीं
क्यों
सर।
नहीं आया? नहीं नहीं, रिजल्ट नहीं आया उसका कोई दूसरा रीजन होगा. या तो कब आया रिजल्ट?
आज आया सर।
सर अभी थोड़ी देर पहले।
5-10 मिनट पहले आया।
हाँ तो बाकी की वो सब तुम्हारा भी आ जाएगा, वही अपलोड कर रहे होंगे वो, क्योंकि तुम्हारे मार्क्स तो चले गए. बाकी जो रोल नंबर चेंज होने की बात है वो तो हमने उनको बोल रखा है, उनको अपने सिस्टम में चेंज करना है. वो उन्होंने अभी तक किया नहीं है ना. वो उनको अपने सिस्टम में चेंज करना है, वो कर देंगे. उनको एक बार बोलो, तुम लोग भी बोलो, मैं बोलता हूँ फिर एचओडी सर को. ठीक है, ये वहां पर
मैंने एचओडी सर को बोला भी था।
हाँ हाँ फिर बोलते हैं एक बार, है ना. वहां पर भी क्योंकि वो एग्जामिनेशन सेंटर को करना है, वो हमें डिपार्टमेंट से करना होता तो हम कब का कर देते हैं. एग्जामिनेशन सेंटर को करना है, करवाते हैं वो.
सर आईडी कार्ड पे भी पीएस लिखा आ गया है अब।
वो भी चेंज करवा देंगे, वो सब चेंज होगा वो, क्योंकि तुम्हारा रोल नंबर चेंज होगा तो पूरा चेंज होगा.
हाँ सर, वो जल्दी हो जाए नहीं तो, क्योंकि सीनियर्स ने बोला है कि बाद में जब प्लेसमेंट वाले आएंगे तो वो पूछेंगे पीएस का क्या मतलब होता है, फिर जवाब देना पड़ेगा और बहुत सारे प्रॉब्लम्स है।
ये ना एप्लीकेशन लिखो तुम लोग अलग अलग, है ना, और वो दो हमें, हम डीन जी को भेजते हैं सारी एप्लीकेशन की, रोल नंबर चेंज किया जाए बच्चों का.
ठीक है सर।
है ना. हाँ चलो ठीक है, फिर मिलते हैं. नेक्स्ट क्लास कब है? ट्यूसडे. तुम लोग का टेस्ट लेना है. टेस्ट कब दोगे तुम लोग? इस मंडे को?
नहीं,
इस मंडे के बजाय एक काम करते हैं, तुम्हारा
और
करते
मंडे
हैं
को
हम.
नहीं, मंडे को मैंने आउट ऑफ स्टेशन जाना।
तो संडे को ले लो, अगले संडे को।
नहीं
संडे
संडे
या
नहीं
सैटरडे
रखेंगे, नहीं मंडे ही रखेंगे. मंडे
नेक्स्ट मंडे, नेक्स्ट
नेक्स्ट टू नेक्स्ट।
हाँ तो
हाँ.
नेक्स्ट वीक चलो, अभी पढ़ाई की तैयारी नहीं करी है अभी।
और अभी
Yes,
बाकी
लेकिन
सब्जेक्ट का भी हो रहा है।
एक काम
और
करते
सर
हैं
एक
Wednesday-
बीच में सर एक डाउट सेशन भी रख लेना सर एक बार।
ठीक है, पर तुम्हारा सिलेबस बहुत ज्यादा हो जाएगा फिर. नेक्स्ट टू नेक्स्ट मंडे, दैट इज 26.
सर आप एक सिलेबस पे, लेकिन मतलब कोई मतलब बता देना कौन सा कितना पोर्शन करना है, और एक बार डाउट सेशन रख लेना बीच में।
ठीक है, 22 हो रहा है मंडे, 22 को रखते हैं. ठीक है, कोई दिक्कत नहीं है. 22 को एग्जाम रखते हैं तुम्हारा.
ठीक है सर।
ठीक है चलो, डाउट सेक्शन रख देंगे, बीच में कुछ पूछना हो तो पूछ लेना. ठीक है.
सर नेक्स्ट वीक वाला वेडनेसडे क्लास में रख लेते हैं डाउट सेशन।
हाँ ठीक है, नेक्स्ट वीक में वेडनेसडे में पूछ लेना आप जो भी पूछना है ना.
ठीक है सर।
चलो.